Hello and welcome to DevTut Academy. Today we are going to be looking at solutions to some of the questions on Waec 2016 objective paper on circuit theorems. And like I've said in my previous videos, having an understanding of the principles of circuit geometry is going to help a lot. And today, using those applications, using those theorems, we are going to be solving all these questions together. And first on our list is question number 18, that we are given the diagram and we are told that YW is a tangent to the circle and UV and UX are equal in length, and we are given the angle VXW to be 50, and that's to find the value of UXY. Now, first and foremost, looking at this question, we can see that angle XUV is going to be angle WXV. And what's the reason for that? Because the angle subtended by the tangent drawn to a circle is equal to the angle in the alternate segment. And so, since that is 50 degrees already, you can see that the two sides that are equal, side UV and VX of the triangle, of the isosceles triangle, since they are equal, that makes it an isosceles triangle. And we know that base angles of an isosceles triangle are always equal. Since the two sides are equal, the base angles are also going to be equal. So we have angle VXU is also going to be angle XUV, and that is also 50 degrees. And looking at this, we know that the UXY that we are asked to find and the VXU that we just found and the angle that we are given VXW, they are all on a straight line. And we know that the sum of angles on the straight line is 180 degrees, and easily that ensures that we can solve our question. And it's as simple as it comes like that, just to understand the principles to apply. There are many ways you can solve this also. Okay, now looking at this question, we're asked to find the value of M, and we're given the angle at the center 10M facing downwards and the angle at the circumference facing upwards as M degrees. Now, applying our principles of circuit geometry, we know that the angle that is subtended at the center of the circle is twice the angle that is subtended at the circumference, and that means that our angle XOZ is going to be twice angle XWZ, and that is going to give us 2M. And now, having that simple understanding has helped us seriously to forge ahead in the solution of this particular question. And we also know that the angle at a point, normally they will sum up to 360 degrees. So angle XOZ plus angle XOZ, the one facing up and the one facing down, they are going to sum up to 360 degrees. That means 2M and 10M is 360 degrees. And solving for M from the question, you can easily get the value of M to be 30 degrees. And that is done and dusted with that question. Just to have an understanding of our theorems and how to apply them, we can find the solution to the questions that are given to us. Now, observing and knowing the principles that we need to apply will always help us to solve our questions. Here we are given a triangle that is isosceles, meaning that two sides are equal. And normally, with that principle, we know that since two sides are equal, the base angles are also going to be equal. But going back to our understanding of circuit geometry, we know that opposite angles of a cyclic quadrilateral are equal. So angle PQR and angle PSR, they are going to sum to a total of 180 degrees. And we are given PQR as 117. And solving for PSR, we can easily get our PSR to be 63 degrees. And now, since we know PSR is 63 degrees, we also know that this other base angle of the isosceles triangle is also going to be 63 degrees. Why? Because base angles of an isosceles triangle, they are always equal. So you can see how the understanding of the principles that guides circuit geometry and triangle properties will help us to solve the questions. And moving on from there, we know that we can easily find angle PRS Moving on from there, we know we can easily find the angle PRS because the sum of angles of a triangle will also add up to 180 degrees. And we have already gotten two base angles of the triangle, both of them having a value of 63 degrees. So our PRS, like that, we can solve by subtracting 63 in two places from 180 degrees. And once we find our PRS, we can now apply another principle on circle geometry to find the requested angle PST. Now our PRS we can solve to be 54 degrees. And looking at this particular diagram, we can see that the angle subtended by a tangent is always equal to the angle in the alternate segment of the circle, and that means our angle PST is also going to give us 54 degrees, which is angle PRS, and that is the simple solution to our question. The key of your printer is to know your principles, familiarize with yourself with them, and also be able to identify that there is an isosceles triangle that will help in solving the question. Another question in the same year, question number 41, we are given again a cyclic quadrilateral. But looking at this question, one of the things you need to understand first and foremost is that there is no line passing through the center of the circle. If a line had passed through the center of the circle, we could have said the angle subtended at the circumference of that particular segment of the circle. Of course, that will make it a semicircle. Then the angle subtended at the circumference will be 90 degrees. But this is not the case in this particular scenario. So we are going to look for a way to solve it. And first and foremost, we know that PQR and PSR, they are opposite angles of the cyclic quadrilateral, and so they will add up to 180 degrees. And now we can see that PSR is comprising of two angles, 60 and 80, and from the solving we can get angle PQR to be 40 degrees. The angle opposite to the sum of 60 and 80 is 40 degrees. From the triangle PQS, we know that we have 100 degrees as one of the angles, we have 60 degrees as another angle. We can find the third angle PQS by solving for the sum of angles in a triangle, which we also understand to be 180 degrees. And in trying to solve that, we can add PSQ, SQP, and QPS. All of them are going to add up to 180 degrees, and easily that can give us our angle SQP, and we can get that angle, which is, remember, is one of the angles that is going to make up 40 degrees that we have gotten before. So since we have our angle SQP now as defined by 20 degrees, we know that SQR can be excluded from PQR by subtracting SQP from it, because both of them, both SQP and SQR constitute angle PQR. So from there we can easily solve for what we're asked to solve for. SQR is going to give us 40 minus 20, and that's 20 degrees, the solution to the question that we are asked. Question 48 in the same year, 2016, Waec question. Here we are given Herman as the chord of a circle with center hole and radius 10 centimeters. Now, from this particular diagram, we are asked to find the length of the chord Herman, but we can introduce a point T on the diagram, and we can see that that is the right angle triangle with 10 as the hypotenuse and 70 degrees defined for us already. Now, from SOHCAHTOA, we know that finding sin 70 is going to give us opposite over hypotenuse, and the opposite in this case is line MT. The hypotenuse is 10, and moving ahead to solve for MT, line MT, we can see that it will give us 10 sin 70, and bringing our calculator, we can get the value of 10 sin 70 to be 9.3969. You should know that we're asked to find the answer correct to the nearest centimeter, but we will do that at the end of our solution. Now, nobody introduced MT for us. We introduced MT, but from what we drew and the properties of a circle, we know that MT is going to be half of MN because a line drawn from the center of the circle perpendicular to a chord bisects the chord. And using that principle, we know that MN is going to be twice the MT that we just calculated, and that is 18.7938. And since the question is asking us to get in nearest centimeter, that will be approximately 19 centimeter. Now, those are some of the applications of the principles of circuit geometry that we can make use of in solving our questions. And that's all we'll be having for today. It's Day Academy. If you like this video, kindly subscribe, and God bless you.